This is a buzzer, and this is a 555 timer. They are two components that are commonly used together. Let's start with the 555 timer. The 555 timer is one of the most popular integrated circuits ever created. Its purpose is to generate timing signals and repeated electrical pulses. These signals can be used to create delays, blink LEDs, generate tones, and many other timing-related tasks. Inside the 555 timer are dozens of electronic components working together, including transistors and resistors as seen. Rather than building a timing circuit from many individual components, engineers can use a single 555 timer chip to perform the same function. The 555 timer has 8 pins, each with a specific purpose. When building circuits with a 555 timer, resistors and capacitors are often connected to the chip to control its timing behavior. You can think of a 555 timer like repeatedly flipping a light switch on and off automatically. As the output changes between high and low voltage, a repeating electrical signal is produced. The speed of the switch is determined primarily by the resistor and capacitor connected to the timer. The larger the resistor or capacitor value generally slows the timing cycle down. Smaller values generally make the timer operate faster. Because of this, a 555 timer can produce signals ranging from very slow pulses that blink every few seconds or signals that blink thousands of times per second. The ability to generate repeating signals makes the 555 timer especially useful in a wide variety of applications. For example, it can be used to create a flashing light, timers, alarms, and many other circuits. Now let's look at another component included in this kit. This is a passive buzzer. A buzzer is a device that converts electrical energy into sound. The buzzer included in this kit is passive. Unlike an active buzzer which contains its own internal oscillator and can produce sound simply by applying power, a passive buzzer requires an external signal to generate the sound. Without a changing signal, a passive buzzer will not produce sound as shown when we plug it into a circuit. If this were an active buzzer, it would be producing a sound, since it only needs a direct current. You can think of a passive buzzer as being somewhat similar to a speaker. When an alternating signal is applied, an internal diaphragm vibrates back and forth, creating the sound, based on the signal that is provided. You will see how to make a buzzer circuit in later videos. The frequency of the signal determines the pitch of the sound. If the signal changes slowly, the tone will be lower. If the signal changes rapidly, the tone will be higher. This is where 555 timers and buzzers work together. The 555 timer can generate a repeating electrical signal as explained earlier, and the passive buzzer converts that signal into sound. One reason passive buzzers are popular in projects is that they can generate many different tones depending on the signal rather than just a single fixed tone with an active buzzer. By changing the frequency generated by the 555 timer, we can create a variety of pitches and sound effects. As you continue through this course, you'll build circuits that use both the 555 timer and passive buzzer, giving you hands-on experience on how timing signals can be converted into sound. For now, remember the 555 timer is an integrated circuit to generate timing signals and pulses, while the passive buzzer converts those signals into sound. Thanks for watching, and I'll see you in the next lesson.